Today we're going to talk about linear expressions in the real world. Before we do that, we're going to review a couple of skills. So the first one is writing a percent as a decimal. So when converting a percent to decimal form, we divide the percent by 100, because remember, percent means per 100 or out of 100. So this is the same as moving the decimal point 2 places to the left. So if we look at our example here, 43%, well, that's the same as dividing by 100, or we can move this decimal 2 to the left, which is the same as 0.43. So let's go ahead and complete these underneath. So 52%, 2 to the left would be 0.52, and then we would have 0.13. This one, be careful. We move it over 2, it's going to be 1.04. Fourth one, move it over 2. You can write it as 2.30 or just 2.3. Number 5, if we move it 2 to the left, it's going to be 0.06, then 0.09, 0.075, and 0.021. All right. Now if we go on to our next skill, which is combining like terms. So when two terms have the same variable, they can be simplified into one term by combining the coefficients using adding or subtracting rules for integers. So example, the cost of 6 apples and 7 more of the same apples can be written as 6a plus 7a. Well, 6 plus 7 would give us 13a, where a is the cost of 1 apple. So let's simplify these below. Negative 3x plus 2x. They have different signs, so we subtract. So that would be 3 minus 2, which is 1. The negative 1 is bigger, so it's going to be a negative 1x or negative x. 10a plus 5a, 15a. 12b minus 7b, 5b. C plus 3c. Remember, this has a coefficient of 1, even though it's not written, so 1 plus 3 would give us 4c. Next one, 2d plus 0.5d would be 2.5d. Then 0.7e plus 2e would be 2.7e. F plus 0.2f, remember that's like a 1, so we would have 1.2f. And then last but not least, g minus 0.5g, remember this is a 1, so 1 minus 0.5 would give us 0.5g. All right, let's go ahead and dive into our first example. So writing linear expressions in the real world. So real world scenarios can be represented using expressions instead of words. Sometimes there may be more than one expression that represents the same information. And so we're going to do some examples below. So number 1, Sydney plans to buy a shirt as well as pay a 10% sales tax of the price of the shirt. We're going to write 2 expressions that Sydney could use to calculate her total cost depending on the price of the shirt, S. Well, the first thing we notice is it gives us our variable, and that's talking about the price of the shirt being represented by S. So to get started, what term will represent the price of the shirt? Well, we don't know the price of the shirt. We're just using the variable S to represent that. Well, then if we're talking about taxing the shirt, we have a 10% sales tax. So the hint here, we need to calculate 10% of the price of the shirt. Of means that we are multiplying. So we need to take our 10% and we're going to change it to either a decimal or a fraction. Since we're talking about money, that means we'd probably want to do the decimal one. So 10% would be 0.1. And then we are multiplying it by the price of the shirt. In this case, the price of the shirt is being represented by S, so 0.1 S. going to use the terms above to write a complete expression representing the total cost. Well, sales tax causes the price to go up because it's an addition to whatever we're paying at the register. So that means we're going to need to add these together. So we're going to have 7 plus 0.1 S. Well, then the next expression, we're going to simplify it so that we would only have to make one calculation to determine her total price. Well, remember this coefficient, even though it's not written, is a 1. So we would have 1S plus 0.1 S, or 1.1 S. Now what we're going to do is we're just going to check our work, and we're going to suppose that the price of the shirt S is equal to $20. We're going to replace S with $20 in both expressions above and solve for a final price. So we just want to make sure we did it correctly. So this first expression, we're going to plug in 20 for S, so we have 20, and then plus 0.1, and then this is multiplication even though it's not written, so times 20. Now we need to follow our order of operations, so multiplication would go first. So if we have 20 times 0.1, that would be 20, and then we have one decimal place, so we would need to carry it over 1. So we have 20 plus 2, which would be $22. So that would be the price with tax. Well, we can also check it with our second expression. So we're going to plug it in here. So we have 1.1 times S, which is 20. So if we do a little scratch work, 20 times 1.1, well, we would have 0 and then 2, placeholder 0, and then a 0 and a 2, add them up. Then we would get 220. And then one decimal place means we have to have 1 in our final answer. And so we can see that it equals $22 as well. So in the end, both expressions should produce the same total cost, or the same total price.